Hi, so we're still in 15.6 applications of the equilibrium constant. And what we're going to do now is, instead of calculating the equilibrium constant, we're going to use that to solve for concentrations. Sometimes the question will give you other concentrations at equilibrium, and that's just going to be a plain algebra problem. And other times they're only going to give you starting concentrations, and that's going to be a little bit harder. So we're going to start with one of the easy ones first. At 500 Kelvin, the reaction PCl5 in equilibrium with PCl3 plus Cl2 gas has a Kp of 0.497. In an equilibrium mixture at 500 Kelvin, the partial pressure of PCl5 is 0.80 atm, and that of PCl3 is 0.35 atm. Calculate the partial pressure of the Cl2. So this is a pretty straightforward, because the equilibrium constant expression has the numbers in it. Those numbers that we would put in are the numbers at equilibrium. So this is just going to be a pretty straightforward question. We got that the Kp is equal to the PCl3, the pressure of PCl3, times the pressure of Cl2 over the partial pressure of PCl5. No coefficients, so no exponents. So now we just plug in the numbers. We get 0.497 equals 0.350. I don't need to put the units in because we know the equilibrium constant doesn't have units, times the pressure of PCl2 over 0.860. And I do a little cross multiplication and then division, all sorts of ways that you can do this algebra, but you should get a PCl3 of 1.22, and that obviously it's a pressure, so that does need a unit of atm. It's kind of weird because usually we say like the units got to work out, but because we've sort of arbitrarily said that equilibrium constants don't have units, we just have to, kind of plug in the unit at the end. So this is an easier problem, just simply because all of the numbers in it are at equilibrium. So we can plug it into the equilibrium constant right away. The next type of problem, we can't do that. So if we look at this next problem, it says a 1 liter flask is filled with 1 mole of hydrogen gas, 2 moles of iodine gas at 448 Kelvin. The value, so it's initially given that's not at equilibrium. The value of the equilibrium constant is 50.5. What are the concentration of all those at equilibrium? So we're going to bring back that ice chart again. And this time we're not going to have a lot of data to fill into it. We're going to fill it in with some X's. So the initial, since it's 1 liter and 1 mole, that means that the molarity is going to be 1.000. And this guy will be 2.000. And at the beginning, we will, it says it's only initially given the hydrogen and the iodine. So the HI is 0 at the beginning. That's all the information I know. But what I can say is that this guy will go down by some amount. And because the coefficients of H2 and I2 are both 1, I2 will also go down by that same amount. The HI will go up by twice that amount because its coefficient is 2. So now I can actually write that bottom row in. This will be 1.000 minus x, 2.000 minus x, and 2x. I know the Kc. I know that would be, the formula would be the concentration of Hi squared over the concentration of H2 times the concentration of I2. So now I'm just going to plug in all the numbers that I know. I know that the Kc is 50.5. I know the concentration of Hi is 2x. And I'm going to square that. Divided by the concentration of the H2, 1.000 minus x, times 2.000 minus x. And although this may seem like a sort of daunting algebra question, well, it kind of is a daunting algebra question. It's just algebra. It's an equation. It's got one variable. The biggest exponent is going to be squared, which means no matter what, I could use the quadratic formula in order to find what x is. And then once I find what x is, I can plug it into this row in order to actually solve this equation. Okay, so the steps for how to do these are written there, and you can see that we've done most of them. Write the change in equilibrium as x and account for stoichiometry. We did that. Calculate the equilibrium concentrations with x in them. Plug into the equilibrium constant. And now we're on to step 5. Make equal to 0 and use the quadratic formula to solve for x. One of these answers will not make sense, and I'll show you what we mean by that. Then go back to the equilibrium line of the ice chart, plug in that x, and get your answers. Okay, so all I'm going to do here is go through the algebra and get it into the format of a quadratic equation. You may not need to go through this whole thing. You guys are pretty advanced in math, so the first thing that I'm going to do is actually FOIL the denominator of this. So I'm going to say 50.5 equals 4x squared. I'm just going to actually do that out, get that out of the way. And then first is going to be 1 times 2, 2.000. And then outside inside is going to be minus 1x plus minus 2x, or minus 3.000x, and then plus, because negative times negative is a positive, x squared. Now multiply, kind of cross multiply here, right? And we get 50.5 times 2, or 101 minus 151.5x, and then plus 50.5 x squared, and that would be equal to 4x squared. Now I'll get everything onto one side by subtracting 4x squared from both sides, and now I'm also going to rearrange my quadratic so it's in, ax squared plus bx plus c format. So I would have to combine the like terms of the x squareds. So 46.5 x squared minus 151.5x plus 101 equals 0. Now this is what, if you have the program quad form in your calculator or some other quadratic solver in your calculator, you can just plug that in. You can obviously do the full quadratic formula to get the x's. I don't have any of those, but you just Google on a computer or iPad quadratic formula solver, and it will ask you to put in your A, your B, and your C. Remember to put in the signs, and it will give you the two x's. This is not something that you're going to be asked to do on the AP exam, because this would obviously be a big advantage to people who have graphing calculators and students who have formulas plugged into their graphing calculators. And because of equity issues, they don't put questions like this on the exam. They put questions like this, well, you'll have to do this, but the math will work out so that you don't have to actually use the quadratic formula. I think we'll see an example of one of those in a moment. I plug this in and I'm going to wind up getting two x's. I get two x's. X is equal to 2.323 and x is equal to 0.93498. Now I look back at my ice chart and remember that the ice chart said it was 1.00 minus x. When I said one of those will not work out, can you see how x can't be 2? I'm just going to go back up to my ice chart here. So x can't be 2 because then I would have a negative number for the concentration of H2 and I2. So x is going to obviously have to be that other number, that 0.93498. So x is equal to 0.93498, and then I can just simply plug in those, plug in x in this formula to get my equilibrium concentration of these. So at equilibrium, the concentration of H2 is going to be 1.000 minus 0.93498, or 0.06505. The concentration of I2 will be 1.06502, and the concentration of HI would be 2x, 1.869. These would all be in molarity, obviously. Have to round for some significant figures here, probably just round to 3 significant figures for all of those for my final answer. So what I have, you can this is how the problems in the textbook and the problems that we're going to do here for practice, you will need to use the quadratic formula. But the way that the College Board has done it in the past, they have made it so that the algebra is pretty simple. You can imagine if the starting concentration of H2 in this problem were 2, just like the other one, then wouldn't that bottom be the same thing? And I could just put them together and square it and then take the square root of both sides. So you can see they can do like fancy stuff to make the algebra nice and work out. So we have one more of these to try. So if you think you got it, you can give it a try on your own, or you can just go through the problem with me. For the equilibrium PCl5 in equilibrium of PCl3 plus Cl2, the equilibrium constant has a value of 0.497. A gas cylinder is charged with PCl5 at initial pressure of 1.66. What's the equilibrium pressure of everything? So I'll fill in my ice chart. This would be PCl5 in equilibrium with PCl3 plus Cl2. And all I'm given is that PCl5 is 1.66. And these guys are 0, and this guy must be minus x plus x plus x. 1.66 minus x, xx. Right, Kp, which is equal to 0.497, is equal to the partial pressure of PCl3 times the partial pressure of Cl2 over the partial pressure of PCl5. So 0.497 is equal to x times x over 0.166 minus x. 0.497 equals x squared over 1.66 minus x. Cross multiply, I'm going to get 0.82502 minus 0.497x equals x squared, or 0 equals x squared plus 0.497x minus 0.82502. Plug this into the quadratic formula, however you know how to solve it, on a calculator or computer, or just using the actual quadratic formula. My x's is negative 1.190 or 0.693. Now it's not going to be negative because then we would have less than 0 Cl2. So this is the one that we cross out. That must be our actual x. So 1.66 minus x is going to be 0.967 ATM. And this guy would be 0.693 ATM and 0.693 ATM. Okay, so kind of messy, but it's just algebra. You can definitely do it.